Okay, so let's look at team challenge number 6, which is a typical exam type question of drawing a titration curve. Now, the question indicated that this was 62.5 mils of 20 millimolar, and you're titrating with the addition of 0.1 molar NaOH. Okay, so the first thing to do, and the hardest part for most people here, is to figure out what an equivalent is in this question. Equivalent is the number of moles of weak acid that you have in that beaker to start with. You know, you've got a beaker here, and you're doing a titration, and you're adding drops of acid base to in this case. But the key to start with is how many moles do we have in there to start? Because that's the definition of an equivalent. So we have to figure out how many moles of material we had there. And it turns out that that number is 0.00125 moles. That is what an equivalent is in this experiment. Then, when we go to figure out our table, to figure out how many equivalents we add when we add 1 ml of base, we can figure out what we're doing. 1 milliliter of base, which is 0.001 liters, at 0.1 moles per liter, is equal to 0.0001 moles. Okay? That's how many moles we've added. Let's divide that by the number of moles in an equivalent, and we'll get an answer in equivalent. Okay? Turns out this is 0.08 equivalents. Okay? So we can put that number in here. Now, 2 ways you can do this. You can do that math for every one of these points to figure out how many equivalents, or you can use the Jen Conley method and just say, well, if 1 mil is equal to 0.08 equivalents, just multiply that times 2.5 times 5 times 7.5 and so on to fill in the table. I'll let you do the math, but I'll show you what I got for answers. So we have 0.2, 0.4, 0.6, 0.8, 0.96, 1.2, 1.44, 1.68, and 1.92. So now we know how many equivalents and what pH that gave us. Now we're going to plot a graph. We are going to use equivalents, that's our unit, equivalents, spelled correctly, of OH minus added on the x-axis, and we're going to plot pH on the y-axis. So I'm going to call this 0.5 and 1 and 1.5 and 2. Okay? And I'm just going to work up here. Alright. And then I'm going to plot these points on the graph. That's a little bit tricky when you have no grid lines here, but I'll attempt to put them in as best I can. 3, okay. Like I said, not the easiest to plot them this way, but we'll do it anyway. Somewhere up here. 0.96 is at 4.98. That's somewhere in here. Big jump here because we're working into the next pKa. We've passed 1 equivalent. And we're up here at 8.6 somewhere. 9.1. I'm really getting off kilter here, but anyway. 0.68 is about there. 9.5 somewhere in here. And finally, somewhere up here. Okay, so we have a titration curve with 2 flat spots, or 2 pKa's, and we would sort of connect the points something like this, and eventually go up like that. Now, if we were doing this experimentally to figure out the pKa's, we would go up from 0.5 equivalents and read over, and we would go up from 1.5 equivalents and go over. Okay? That's the way we would do it. You could do that on your graph. My graph is too crappy for that. You can then check your answer, though, by picking any one of these data points. Let's, for instance, I think I picked this one. And I said, okay, well, let's look at this information right here. I said, all right, my pH is equal to 3.42, which is equal to the pKa that I'm looking for, that's my unknown, plus the log of. Well, I've added 0.4 equivalents of my base, so I must have 0.4 equivalents in A minus, and I must be left then with 0.6 as HA, because I had 1 to start, and I moved 0.4 up there. So if I turn this around to solve for pKa, is equal to my 3.42 minus the log of 0.4, 0.4 over 0.6. And what this gives me for a pKa, if I solve it out, was 3.6, I do believe. Okay? All right. And you can do the same thing by choosing one of these points over here and saying, okay, so remember to ignore the first equivalent when you're doing this. You could say 0.2 over 0.8, take the log, and you could determine the pKa by using the pH of 8.6. So just be careful when you're plotting these to make sure that you have clearly labeled x and y axes, and that you are mindful of whether you're adding base or acid. When you're adding base, the pH goes up. When you're adding acid, the pH is coming down. And key here is figuring out what an equivalent is in your problem.